Good evening to one and all present here. I am Arundhati Mukherjee from Revered Media. We welcome you all to today's webinar on the topic Durability and Sustainability of Concrete Structures. This webinar is organized by Indian Concrete Institute New Delhi Center in association with Civil Engineering and Construction Review, powered by Revered Media Private Limited. We would like to begin this webinar by welcoming Engineer Rajiv Singhal, who is the Chief Engineer in CPWD and Chairman, Indian Concrete Institute, New Delhi Center. We welcome you, sir.
Thank you. Thank you. Good afternoon, everybody. On behalf of New Delhi Center of ICI, I welcome you all to this webinar. This is the 6th webinar in this series, which we started on 31st of July. Am I audible?
Oh, yes.
This is the 6th webinar in this series, which we started on 31st of July. And since that date, we are holding a webinar on every Saturday. Now, a brief about New Delhi Center. It's one of the 44 centers of ICI, which, as you all know, is a non-profit organization aiming to promote concrete technology and its applications. ICI was established in 1982, and now it has 44 centers, and New Delhi Center is one of them. We have only 300 members, out of around 30,000 strength of ICI. And I would request all the participants in this webinar to kindly enroll themselves with the ICI-NDC. And the forms are available on the website, or if not, they can contact me or our honorary secretary, and we will be there to help them out. So, like Delhi has a population of more than 2 crores, and I think there are more than lakhs of civil engineers. And it's very shocking that only 300 of them are members of NDC. So I would again request you all to become members of ICI, and you will not regret joining ICI. We are having wonderful lectures from all the centers. Now, New Delhi Center aims to organize Concrete Day on 18th of September. Last year also we held it online, and this year also we will hold it online on 18th. And there was a conference, ESICON, which we are supposed to hold on 24th and 25th of September this year in Delhi in physical format. But due to this pandemic, we had to postpone it. Now we'll try to hold it in the first quarter of next year if the situation permits. And let's see how the situation pans out. I welcome you all once again to this webinar on the durability of and sustainability of concrete structures by Dr. M.R. Kalgal. And I also welcome Professor Manu Santhanam of IIT Madras as the panelist. Thank you. Thank you.
Thank you, sir. Introducing to you all Engineer Supradeep Das, who is the current Vice President, North, Indian Concrete Institute and Vice Chairman of BISCED 41 Committee.
Thank you, Arundhati, and good evening to all. It's a great pleasure to welcome you all to the webinar on durability and sustainability of concrete structure, being presented by our esteemed guest, Dr. M.L. Kalgal. Incidentally, he is our ex-ICI National President, and Professor Manu Santhanam from IIT Madras. The webinar is the 5th in the series and is being organized by ICI New Delhi Center in association with CE&CR. I wish to thank ICI-NDC, its executive committee, members, our national president Vinay Gupta, for organizing series of webinars in the present time. For the benefit of attendees and participants, I now present a small slideshow on ICI, which will focus on the brief activities of ICI.
Share your screen.
It is not coming.
Yeah, now I think it is shared.
I think
No.
no.
Presentation is not open yet.
It is not. No, it is not there. No, it is not showing.
Share screen and go to your presentation now, wherever it is, and open that.
Can you see it?
No, sir, not yet.
Not visible.
So please open your PPT first, then try to share your screen.
I have opened the PPT.
Now, sir, click on share screen.
I am doing it. No, it is not coming.
Just a minute, sir.
There is some problem somewhere.
Just a minute. Let me see if I have your presentation.
You have.
Just let me check it. Let's see. Yes,
Can you
I have
open
it,
it?
sir. I will do it for you.
Okay, you read that.
No, I will do it for you. You can see, sir.
Okay.
Sir, you can stop. You can start now.
Can I start now?
Yes,
Okay.
yes.
So, okay, Indian Concrete Institute, it's one of the premier professional body on the cement, concrete and construction technology. We have a new website, that is www.indianconcreteinstitute.org. As already informed by Rajiv ji, that it was founded in 1982 with its headquarters at Chennai. ICI has got around 13,000 members at 44 centers spread across India. We have got around 351 organized members and 267 student chapters. Objectives of ICI are the promote growth of concrete construction and its specialization, to disseminate the knowledge and information for needs of changing concept, to train personnel, collaborate with national and international agencies, creating a better understanding between cement and concrete construction technology, to identify R&D issues, outstanding achievement in concrete construction technology through institutions. We also to collaborate with national and international agencies like ACI, Asian Concrete Federation, Singapore Concrete Institute, Concrete Institute of Australia, to distribute awards for achievement in concrete construction technology, to arrange lectures on selected topics of relevance to concrete construction. We have ICI also organizes periodical seminars, conferences, workshops, exhibitions on the subject, on arranged lectures. ICI publishes quarterly journals containing peer-reviewed technical papers, technical abstracts from 40 journals. ICI also brought out a number of publications and monographs on various related topics. Advisory service. ICI offers an industry advisory service for problem solving in design, construction, maintenance, and repair. It has folded the captains of construction industry, building materials, manufacturers, leading consultant, designers, civil engineers, contractors, educational institutions, lab equipment manufacturer, material testing laboratories, and students. The knowledge dissemination through workshops, seminars, webinars, exhibitions, seminars, technical programs, technical documents. We also have around 11 technical committees. They deal with the various issues of the related to cement and concrete, like fiber reinforced concrete, recycling of C&D waste, decorative concrete, reverse sand, guidelines in specifying durability, industrial flooring, repair, rehabilitation of structures, and mechanized sand. And through this technical committee, we have come out with around 10 technical publications. Their hard copies are available with us. You can, if you can download from our website. Otherwise, you can check up with the state chairman, secretary, or the vice president for a hard copy. We have joint initiative with government bodies, CPWD, BIS, BMTPC, CBRRI, municipal bodies, state PWDs, IRC. We also have headquarter awards, that is lifetime annual awards, lifetime achievement awards for each zone, outstanding concrete technologies, innovative application of special concrete, Dr. Ramakrishna award for best project with precast concrete in India, outstanding pre-stressed concrete structure, young scientist award. We also have two branded events. They are basically ACCon, which is celebrated in every 4 years, and IWC, that is celebrated every 5 years. They are the two international events, and it's a unique platform for the experts from all the participants and share their experience and knowledge. This year, we are going to, basically in 2020, we are supposed to organize the ACCon, but somehow due to pandemic, it has been postponed to 2021, and hope so maybe in December this year or March next year, we will be going to celebrate ACCon 2020. Concrete Day, it's a very important event for ICI. This is the 7th, organized every 7th September every year. We celebrate, all the centers celebrate. This is the day we formed the ICI was formed. Then we have got student chapters. Any having a more than 50 students can have a student chapter. We have around 237 students. Student chapters. Next. Our growth is undeterred, goals are high, targets are far-reaching. We remain committed to the society at large and concrete lovers in particular. Thank you. I am also pleased to announce the collaboration between ICI-NDC with CE&CR and Revered Media for online and physical events. The webinar today is the 5th product of the association, and we propose to have series of such events online, physically, jointly in the coming days. I would now present CE&CR Revered Media to all.
Civil Engineering and Construction Review, a leading infrastructure monthly on methods, materials, and machinery. Celebrating 34 years of publication. CE&CR is India's #1 infrastructure monthly news journal for the past 34 years. We have been providing discerning knowledge and an unmatched coverage of the construction sector since 1988. Get social with the largest online construction media network of India. Civil Engineering and Construction Review provides a valuable, informative, unmatched high-quality content. It is the most circulated magazine in India, having a readership over 17 countries worldwide. Google ranked #1 under the search of Civil Engineering Magazine India and Construction Magazine India. We have a 5-star rating as well. Currently stands at 58,000 plus followers on Facebook. 16,500 plus industry professionals connected on LinkedIn. You can also find us on other social media platforms such as Twitter, YouTube, Instagram, and SoundCloud. No one around us in India. CE&CR has been awarded the prestigious Best News Magazine by CIDC in the year 2014 and 2019. Best Publication Award by the ACCI in 1991. Designated for International Quality Summit Award in Gold category in Paris by BID in the year 2012. We cover topics such as roads and pavements, bridges, construction equipment, concreting, precast, high-rise structures, waterproofing, and many more. CE&CR is read by construction companies, contractors, builders, government departments, public sector undertakings, building material and equipment manufacturers, consultant and architectural engineers, research institutes, polytechnics and colleges. Connect with the most circulated and trusted magazine in India.
Introducing Revered Media, a 360 degrees logistics solutions of business events. Who we are and what we do. Revered Media is an independent, full-service, professional logistics solutions company for business events. We specialize in corporate events with end-to-end event project management. Our commitment is to see each event through from the start to finish, while keeping the goals, vision, budget, and our clients' needs in mind at all times. We manage your events from conceptualization to execution, saving you the long hours, late nights, and endless emails so that you can focus on what's essential to you. We represent leading international exhibition organizers for promotion of their shows in India as well. Our unique selling proposition are: we have a focused and contemporary approach, wide contacts, rich experience in conceiving and managing high-profile events, working within deadlines and budget with maximum mileage and strong marketing instincts. We specialize in various types of events such as webinars, seminars, conferences, exhibitions, social media marketing, EDMs and e-newsletters, workshops, promotional advertisement and designing, public relations, product launch, award ceremonies, road shows, and many more. Our vision includes growth, innovation, affordability, and quality services. Contact us and join hands with Revered Media.
Introducing our moderator for the day, Dr. VVL Kanta. He is the Senior Principal Scientist in Bridge Engineering and Structures Division, CSIR, CRRI, and Honorary Secretary of Indian Concrete Institute, New Delhi Center.
Good afternoon, all. It's my privilege today to introduce the speaker and the panelist for this today's webinar. Our speaker is Dr. M.R. Kalgal. Riddhi, can you show his profile, please? Yeah. Dr. Manamohan Kalgal. He was the past president of Indian Concrete Institute and the past vice president of IAStructE. He is also technical advisor of UltraTech Cement. He did masters in precast concrete and PhD in concrete structures from Indian Institute of Science, ISA Bangalore. He spent more than 20 years in teaching, research and consultancy. He was a professor of civil engineering at MS Ramaya Institute of Technology, Bangalore. He moved from academics to industry in 2005. He was heading technical division of precasting company BBR till 2007. He joined UltraTech Cement Limited as head building products division and later took over as a joint president and head technical services. He is presently technical advisor to UltraTech. He is actively involved in several professional bodies, like he is a fellow of Indian Association of Structural Engineers and he is ex-vice president of South of ICI. He is fellow of Association of Consulting Engineers, Civil Engineers, India, and ex-secretary general. He was a member of Indian Concrete Institute and was a past president of ICI during 2015 to 17. He was also vice president of Asian Concrete Federation, ACF, for the years 2017 to 2018. And he was actively involved in organizing several national and international conferences. He was AICTE INIE Distinguished Visiting Professor to BMSCE from 2012 to 2017, has been honored with the Eminent Engineer Award by Institute of Engineers at their annual convention 2018. Irkeri Concrete Congress honored him in March 2019 by facilitating and by dedicating one of conferences in his name. Next, please. Now, Professor Manu Santhanam. I don't think anybody doesn't know him. He is a very well-known personality in the field of concrete technology. He's a professor of civil engineering department in IIT Madras, Chennai. Professor Manu Santhanam, he obtained his BTech degree from IIT Madras in 1994, followed by MS from Purdue University in 1996. After more than 2 years with CECA Corporation USA as R&D chemist, he went back to Purdue University for his PhD, which was completed in 2001. On the topic of sulfate attack of concrete. He joined IIT Madras soon after the completion of his PhD. Professor Manu Santhanam specializes in research and as a cementitious on cementitious materials from an interdisciplinary approach, wherein sophisticated analytical techniques from chemistry and materials science are used to explore the link between microstructure and performance of cement-based materials. The primary focus of Professor Manu Santhanam's research has been the performance of concrete prepared with supplementary cementitious materials. The gamut of investigations conducted in various research projects on this aspect include the understanding of fresh state properties such as rheology and setting, as well as hardened state characteristics, including strength and durability. The development of post structure and its impact on the early and long-term properties of cementitious systems modified by SCMs is a recurring theme in the projects executed by Professor Manu Santhanam's group. While the work has led to substantial improvement in the understanding of conventional SCMs such as the fly ash and the slag, the systematic characterization of techniques used in the projects have also led to the development of alternative supplementary cement materials such as sugarcane bagasse ash and limestone calcined clay blends. Professor Santhanam's group work has been pivotal in bringing forth the excellent performance of such binder systems with respect to durability against chloride-induced corrosion and also the enhancement of service life in aggressive environments. Professor Santhanam's group has also been involved in research on 3D printing for the past 4 years. The focus of the group is to enable large-scale 3D concrete printing. Professor Santhanam has published more than 150 papers in the peer-reviewed journals and conferences, and is on editorial board of Cement Concrete Composites, ACE Journal of Materials in Civil Engineering, Journal of Sustainable Cement-Based Materials, and Advances in Cement Research. With this, I welcome Professor Manu Santhanam as our panelist. Now I hand over the podium to Professor M.R. Kalgal to deliver his lecture, please.
Thank you, Dr. Kanta Rao, and very good evening to the esteemed people on the panel, Professor Manu Santhanam, Rajiv Singalji, Supradeep, and all others who are here today to discuss about the durability and sustainability of concrete structures. So I would straight away start my presentation. Hope my presentation is on. Yeah. So the topic that is chosen for this evening is durability and sustainability of concrete structures. With apologies to all the audience, I am slightly changing the sequence. I am speaking on sustainability more, and of course, durability being a subset of sustainable construction or sustainable concrete. I'll be taking it up in the latter half. So let's talk about sustainability. Of course, sustainability is a word which is ubiquitous. Everybody talks about it, and everyone has his own definition of sustainability from their own perspective. All of them are right, and all of them in their own context might be the same. So we in the construction field, when we talk of sustainability or sustainable development, we talk of a development which recognizes the needs of everyone, obviously, maintains stable levels of economic growth and employment. It also uses the natural resources abundantly but prudently, while protecting and, if possible, enhancing the environment. So normally people talk of, the three pillars of sustainability, that is the social, economic, and environmental aspects. So a development which takes into consideration the social aspects and also the economic needs or economic aspects is called an equitable development. A development which takes into consideration the environmental aspects and the economic feasibilities is called a viable development. And a development which takes into account the environmental and social aspects is called a bearable development. The one which takes into consideration all the three is called a sustainable development. And that's the understanding with which we will go forward. Now, everybody is talking about carbon dioxide emissions and the pollution that's being created all over the world. And this is one such pie chart. You will find hundreds of them on the internet. This is updated August 12th, 2020. Hence, I have chosen this. So you will see here that the majority of the carbon dioxide emissions is from China, followed closely by United States. And the rest of the world is 21%. But if you look at the country-wise, after China and United States, it is India. Although it's not as alarming as that of China and USA, the picture appears very grim in India because we are planning to have very large growth in the next decade or so. And obviously, along with the development, the carbon dioxide emissions or the pollution potential is likely to go up very high. And hence, we need to be concerned. We are also a part of an agreement to reduce the carbon dioxide emissions worldwide. We are also a part of it. We'll come to that a little later. So why building sector is obvious that anybody who's been to a building site has seen this kind of environment. Other than this dust that you see around in construction, we also see that the building sector is the single largest contributor in global GHG, with approximately 1/3 of global energy end use taking place within the buildings. The construction sector is said to be responsible for more than 1/3 of global resource consumption, including 12% of all the freshwater use, and significantly contributes to the generation of solid waste, estimated at about 40% of the total volume. And hence, building sector is central to any attempt to use resources more efficiently. And hence, the government of India is also seized of this challenge that we are facing in upkeeping the promise that we have made to the world bodies in terms of reduction in pollution. So, with a population rapidly approaching that of China, and we are crammed into just 1/3 of that area of China, and India then suffers from the resource scarcity on a level unlike any other nation. So we should be concerned about the resource depletion as well. So people talk of green construction, but green construction is not just about building materials only, but there is a lot of it which is connected to the entire conceptualization to construction to maintenance and so on of the buildings and infrastructure. So the general principles of sustainable construction has 4 tenets, which are the reducing of the energy in use. That is, when the building or the project, this structure is in use, the amount of energy that is consumed, how do we reduce that is one of the primary goals of sustainable construction. Minimizing the external pollution and environmental damage is the next target. The third target is minimizing internal pollution and damage to occupants' health, and also reducing the embodied energy and resources depletion. So we generally as civil engineers right now talk of the first and the last targets that are there. The rest of it, of course, is a matter of how we use the building, how we plan and maintain the building. So for a building to be sustainable, if you consider the entire life cycle of the building, they consume resources that far exceed the one which is associated with the original construction. Yes, we do consume a considerable amount of energy and cause environmental pollution, but over a life cycle, if you look at the entire life cycle, because of the energy that is required in operation and construction that is there in maintenance, is likely to consume a lot of resources. And we should remember that people are at the core of sustainability, and how people use these buildings makes them either sustainable or unsustainable. I have seen people who put on their air conditioners and keep their doors and windows open, which means you're trying to cool the entire world, which is against the tenets of sustainability. Hence, it's important to educate people as to how they should use the facilities and appurtenances that are there in their buildings, so that we have a sustainable building to use. So the challenge is to study the people-focused systems and derive the models and theories that explain and describe these systems, and identify solutions which would reduce any adverse effects of buildings on the environment. This is being tackled jointly by the architects and the engineers together to make sure that the entire impact is much minimal. So the solutions will most likely involve innovative technology for new and improved products and also processes. There are several rating systems which are becoming popular now. Of course, they are not the ultimate, but at least they become very handy in following certain basic rules and make sure that the buildings are constructed, planned and constructed and maintained as per the tenets of sustainable buildings. So the leading ones are the ones from the USGBC or IGBC called as LEED Green Building Rating System. And we also have the GRIHA, which is developed by Terry along with Ministry of New and Renewable Energy, Government of India. There are many more which are there world over, and the basic principles are same, but they come very handy in at least managing the situation. Now, when we talk specifically about materials and evaluating materials, there are several aspects that one considers for evaluating the materials that we use in construction. So these are like local availability, embodied energy, percentage of recycled waste materials within that building material, rapid renewability, recyclability of this, durability, contributions in energy efficiency of buildings, and other environmental impacts. So the primary materials that we normally consider in building construction are the concrete and mortar making materials, which consume a very large amount of volume as well as energy. And these can be subdivided into aggregates, fine aggregates or coarse aggregates, and cements. Also, another major part of the building is the walling material, which could consist of clay bricks or concrete blocks, solid or hollow, or presently even AAC blocks. Now, coming closer to our topic, which is concrete, it's not the color that you should look at, but the green benefits that we have in using concrete, which is when you consider the life cycle of this entire concrete, it is said to be the sustainable choice for construction, because all other alternatives are, when you look at the entire life cycle, where we consider the extraction, processing, construction, operation, demolition, and recycling of the material that you are using for construction, concrete makes a significant contribution to the triple bottom line, of the sustainable development. But then we are not stopping at that, saying that concrete is the most sustainable amongst what is available, but we want to see how to make it more sustainable. So what are the choices that we have? The choices that we have are to make cement more sustainable, because that is the most polluting material within concrete. So how do we try and make cement more sustainable? It's by using less energy intensive kilns during manufacture, use supplementary cementitious materials so that we reduce the clinker component or the OPC component, because the word that people normally use, that 1 ton of cement production produces 1 ton of carbon dioxide footprint, is basically for the production of the clinker, that is the OPC. So if we use supplementary cementitious material, we not only reduce the clinker content. Suppose you are using fly ash 35%, you are reducing the clinker content by 35%. And if you are using slag upwards of 50%, you will be reducing the clinker content to less than 50%. So it will be 40% or 45% or whatever that is there. And you also make sure that by using this supplementary cementitious material, you make a better concrete than what it would have been if it was a pure, clinker oriented or OPC cement. We also try to use, new types of clinker, and we use alternative fuels and renewable energy during the production process. And we also try to produce clinker-free cement. Now people are talking, of geopolymers, which is a very promising material. So that is a clinker-free. What I mean by clinker is this OPC clinker. So there could be these alternatives to make the cement more sustainable. There is also a possibility to make the concrete sustainable with alternative materials. Of course, the cementitious, supplementary cementitious materials are also a part of the alternative materials. But if you look at aggregates, you can use recycled aggregates or secondary aggregates, which is a big topic by itself today. We can use wastes, trying to convert the liabilities into assets, wastes as reinforcement, wastes as special additives, and so on. We can try to make concrete more durable. So the longer the building lasts, lesser is the demand on reconstruction or rebuilding, and again resource depletion, pollution, and so on. So durability happens to be a subset of sustainability. That's why I thought it better to deal with durability as a subset of sustainability and focus more on sustainability. So these are some of the alternatives to make the concrete more sustainable. In addition to that, now efforts are on to capture and sequester carbon dioxide in cement manufacture or any other industry, and sequester them in the concrete, or sequester the carbon dioxide in the bedrocks and so on. There is also effort to produce clinker-free concrete, just like geopolymer concrete. There are two words, geopolymer, cement, geopolymer, concrete. So this appears in both places. So if we are planning to use any alternate material, we have to go systematically and analyze and find out that what are the benefits that accrue by the use of these alternate sources. That involves the characterization of materials. Any material that you choose as an alternative to present conventional materials of concrete, you have to subject it to physical and chemical characterization, and also study concrete made with these alternative materials. Again, the concrete in fresh state and hardened state, to see what are the benefits, what are the difficulties, what are the challenges, how to overcome, and so on and so forth. And the third thing is to study the effects of this concrete with alternative materials on the long-term properties and durability. So again, durability becomes a parameter for consideration here also. And once you approve and select materials, you have to also give to the field the appropriate mix design and QA/QC procedures, which might be different from what people are accustomed to in conventional materials. Now, if you look at the cement and how to reduce this carbon dioxide by greater than 1 billion tons per year by 2050, which is a target that cement companies have put for themselves, there are several groups who are working to see how this can be made. Now, there is an association called Global Cement and Concrete Association, which all of you must have heard. This is a a consortium of 40 of the world's leading cement and concrete companies. And from 2020, they have started their efforts to make sure that we achieve our goals for reducing the carbon dioxide footprint. So the ambition statement that they have released, it demonstrates the commitment of the industry across the globe to drive down carbon dioxide footprint, which is the world's most used man-made product, with an aspiration to develop the society with carbon neutral concrete by 2050. Carbon neutral concrete by 2050. So the statement which GCCA has released identifies the essential levers that will be required to achieve the carbon neutral concrete, including these, that is reducing and eliminating energy related emissions, reducing process emissions through new technologies, and deployment of carbon capture, more efficient use of concrete, reuse and recycling of concrete and buildings, and harnessing concrete's ability to absorb and store carbon from the atmosphere. The concrete itself acting as carbon sink. There is also another effort in Europe, which is from the CEM Bureau, which is the European Cement Association. They have been working with the same vision to achieve carbon neutral Europe by 2050. They have put themselves what is called as 5C framework, which is clinker, cement, concrete, construction and built environment, and recarbonation. So these are, the 5 C's that they are planning about. So they are hoping that from, from the 2017 emission levels, they can reduce the, kg carbon dioxide per ton of cement from 667 kgs of carbon dioxide to 227 kgs of carbon dioxide per ton of cement by, optimizing on various aspects, that is decarbonated raw materials, biomass, thermal efficiency, new cements, and then the fuel and electrification effects, and then also try to access the various innovations which are in the pipeline right now, and also access the renewable electricity, high carbon dioxide price parity that is likely to come in the future, and so on. And hence they want to reduce. So this is the first C that they are tackling. The second C about cement, they want to reduce to 550, from 667 to 550 by looking at lower clinker factor, carbon neutral electricity, and carbon neutral transport. And in concrete, they want to look at improved concrete mix design, carbon neutral transport again, and reduce the carbon carbon kg of carbon dioxide per ton of cement from 667 to 608. So all of these, including, of course, the third one, that is construction, where they are looking at leveraging thermal mass properties to cut energy used during the service life of the buildings, and the reduction in the embodied carbon itself in the concrete used in the buildings by using advanced techniques like 3D printing, etc., leading to reduction in the quantum of concrete used itself, and also using the concrete structures adaptability for mixed use in buildings, as well as design for deconstruction. This design for deconstruction is an interesting phenomena where building is conceived at the origin itself with the objective to disassemble at the end of life. This approach will allow materials and components to be removed easily and reused to construct new buildings, which means we are planning for disassembly as well as adaptability for mixed use as, again, a method for reducing the carbon footprint. And the recarbonation is basically, using a natural phenomena where concrete has a tendency to absorb carbon dioxide from atmosphere. So it is said that 23% of carbon dioxide emissions of cement used is being captured annually which means about 8% of savings of carbon dioxide is there automatically happening. So this they want to consider, and enhanced recarbonation of recycled concrete. That is, when you are recycling concrete, when you are breaking the concrete for utilization again as a recycled material, they want to recarbonate this or accelerate the absorption of carbon dioxide by these recycled materials by pumping in exhaust gases from cement kiln or any other captured cement, so that 50% of carbon dioxide can be made to be absorbed. The greater you break them down, the more will be the capacity for it to get carbonated by absorbing these carbon dioxide. So these are the efforts that they are looking at. And also they are looking at, using natural minerals to recarbonate by exposing it to air and kiln exhaust gases and use that as clinker substitutes. So overall effect of this 5C is to bring down 783 kgs of carbon dioxide per ton, which was the value at 1990 levels. It is not 1 ton of carbon dioxide for 1 ton of cement. It had already come down to 0.78 tons. From that 0.78 tons, by 2050, they want to bring it to 0. So this is the roadmap, that carbon neutrality roadmap that people are working on. Of course, GCCA or SEM Bureau, whoever it is, there is a roadmap on which people are working. They are modifying this. A lot of surveys being considered. A lot of engagement with the government is going on in various countries to make sure that the concrete becomes carbon neutral. So worldwide, several hundreds of companies and research groups are working to keep carbon dioxide out of atmosphere, store it someplace else, including deep geological formation, as I mentioned, in bedrocks, soils, soda bubbles, and concrete blocks, and so on. And by making waste carbon dioxide into something marketable, entrepreneurs can begin now raising revenues needed to scale their technologies. There's an interesting competition that happens organized by NRG, COSIA, and COSIA Carbon. This is called the Carbon X Prize, and this is challenge where $20 million is the prize for giving the technology which is the best as far as the carbon dioxide reduction is concerned. So this year the winners were two. That is, the Carbon Cure is one company which is planning, or which is already successfully implemented, carbon dioxide mineralization. That is, carbon dioxide captured from the industrial emitters is purified and stored in stainless steel tanks to the RMC producers in these pressurized tanks. And the liquid carbon dioxide is injected into the wet concrete mix at the time of the manufacture of the concrete itself. You can see the cylinder there, introduced in one of the RMCs. And this carbon dioxide in that fresh state of concrete reacts with the calcium ions from cement to form nano-sized minerals of calcium carbonate, which gets embedded in the concrete, which results in stronger concrete, mix optimization, which is giving you reduction in cement consumption, and also the consumption of carbon dioxide. So the technology can be retrofitted into an existing concrete plant. That's the advantage of this prize-winning technology by the company called Carbon Cure. And the introduction of carbon dioxide does not impact the carbon, concrete's workability, air content, freeze-thaw performance, pH, because that's a question that everybody raises, that if it is calcium carbonate is being formed, pH is going to reduce. No, the mechanism is different. And durability, air content, color, texture, or finish, none of them get affected, but you get a lot of benefits. The other prize winner in that contest was from the University of California, Los Angeles, led by an Indian, Gaurav Sant, and they have come out with what is known as Carbon Built as a company now. So their process locks the flue gas of carbon dioxide into limestone with this what they call as CO2 concrete. So here, this requires very minimal capex, a simple stack tap integration with limited site utility tie-ins. It does not require any carbon capture system, but readily integrates into existing construction supply chain. Basically, very useful for precast applications, and it's already successfully implemented in some plants which are manufacturing blocks, concrete blocks, and so on. So these mixtures can incorporate low-value fly ashes is a great advantage, including those reclaimed from landfills and pond ash and so on and so forth, without compromising on the engineering performance of the equivalent concrete. So this is a significant advantage with this particular method, which now they are calling it as carbon builds reversa technology. So this is the technology that is likely to become very popular, along with, of course, the carbon cure, which is also a technology that is likely to grow very fast even within our country. So this modular technology can be added to any site or permanently embed flue gas carbon dioxide into masonry or precast concrete produced nearby. Okay, there are some few projects I just want to quickly go through, and there is a Swedish project which is including studies of calcination and clinker mineralization formation for carbonate base. All of them are looking at something allied to this particular issue. They're using electrical heating as one of the technologies, carbonation under cooling in high carbon dioxide concentrations, evaluation of technologies aiming at upscaling and determination of gas composition of CO2 rich process gases. So the suitability of these gases for transport, geological and storage will be evaluated. This is just a project which has started. And there are 3 thrust areas that they are looking to finish by 2025, where they are talking about heat transfer with plasma in rotary kilns, direct separation of carbon dioxide from calcination of carbonate-based raw materials, and carbon dioxide-free products with electrified production, reactivity, cement, clinker, and so on. They are also talking about nanomaterials derived from the use of carbon dioxide. This is from a company called Carbon Upcycling, which transforms residues such as fly ash and slag, making them more reactive and increasing their cementitious properties. So the use of carbon dioxide previously captured, is an addition to the cement, which allows the production of concrete with low impact footprint. So I'll rush through now. There is a technology by Solidia, which is a low-lying calcium silicate cement, which cures by reaction with gaseous carbon dioxide. This is another technology that they have been trying to push for several years now. There are some issues. So this is one more technology where carbon dioxide is used in the curing process and captured within CSE-based concrete. So there are several such. This is one from Hofmann Cement. This is more akin to geopolymer. Basically, there are steps called valorization, where we are adding value upon something that is recover and enhance co-products from industry, which are sent to the production plant, like blast furnace slag or fly ash, calcite clay, and so on and so forth. In the production process, the manufacturing process basically involves systematic use of these co-products into the production of the cementitious material using the activators. All those who know about geopolymer know about the role of activators. So this is followed by the packing of cements, bag or bulk or whatever, and sent to the construction site. So in the construction site, these cements are used to serve the 3 main cement markets, like precast concrete, ready-mix concrete, or it can even be used in retail sale. So this company has tried to produce different types of cement, which has given very promising properties and I'll just rush through. These are some of the products that are produced by this company. You can see that basically they are all precast oriented, but precast being the most favored technology now, this has a big role to play there. This is a non-cement kind of application. So they also have this activators and super activators that they have formulated to create what is known as HEV cement, and this cement has a mechanical strength claimed by the company as 60 MPa at 28 days. So this is an ideal road binder, but can also be used for mortars, plaster, and construction of concretes. Virtually no carbon dioxide footprint is there. So people are talking of zero cement concrete. This is again from Australia, and this is for concrete corrosion avoidance in the sewage systems by using this particular cement, which is a composite of nanosilica, fly ash, slag, and hydrated lime. So this is something which they are trying to push and see. They are saying that it can reduce concrete corrosion by 96% and totally eliminates residual lime that is instrumental in the formation of fatbergs, which are very common in sewage systems. LC3, of course, we have an authority on LC3 here on the panel, Professor Manu Santhanam. This is limestone calcined clay clinker cement, which is going to become a reality very soon because the draft code for LC3 is already in circulation. So this is initiated by EPFL, of Switzerland, and the Indian Institutes of Technology, IIT Madras, IIT Delhi, along with Tara. They started, propagating this, and they have interacted with several cement companies, and successfully clay has been calcined and used in production of what is known as LC3 or even LC2. And the process basically consists of finding suitable clay, process the clay, calcine the clay, and then you can make either LC2 or LC3. If you blend, the clinker with the calcined clay and limestone, what you get is LC3. If you blend, only calcined clay and limestone and keep it as a powder, it's called LC2, which later you can blend with, OPC and make and use it in concrete. So here the greatest attraction is that the clay, which is having very low kaolinite content of maybe, let's say 40 or 45%, which is not suitable for other industries like ceramic, paper, etc., which is now lying stockpiled in various places, can be fruitfully used. So the calcined clay that you use is of much inferior quality, and plenty of such clays available across the country in most of the places. So this is another application that people are now going to look at, because the code, BIS also has come out with the draft code, and once it becomes approved, then you can legally use this. So this calcination can be using a flash mixer or a rotary mixer. That again depends on several pros and cons the cement company can look at and add on as a part of the cement company's production facility itself at various plant locations. So there are a lot of advantages in this. The production capacity for cement can be increased twofold without increasing the total carbon dioxide emission. Quarry life can be extended, costly carbon capture storage technologies can be avoided, and the emission of LC3 are estimated to be 20 to 30% lower than that of Portland cement. So the other advantages are that the existing system equipment can be used, the cost of production is lower, and it is a well-known technology because clinker limestone systems and clinker clay systems are very well established. And using low-grade clay and limestone will not require any opening of new quarries or deplete the agricultural soils. So lastly, on this sustainability, people are also talking of protecting concrete by using carbon upcycling technologies, which is by this company called Carbon Upcycling, which has introduced a nanotech coating called alpha carbon, which protects the materials like concrete against acid and corrosion. So it's an effort to convert carbon dioxide into a range of solid nanoparticles useful to all other manner of materials. So the alpha carbon coating is installed already, according to the company's claim, in over 250 locations across US, including franchises of McDonald's, Costco, etc. So the use of these materials, from sustainability point of view, in the Indian context, we have to consider the following points. Concrete construction practices are significantly different here compared to developed countries. Even now, the majority of concrete produced and used in India is by the unorganized sector, who have no clue as to what sustainability is all about, and there are no systems and procedures in place, virtually no awareness about sustainability aspects, no environmental regulations. Even if there are environmental regulations, they are inadequate or not enforced effectively. The engineered or semi-engineered constructions are very limited, or they are limited to larger housing or infrastructure projects. The use of ready mix, where there is a likelihood of optimal use of materials, is just about 10% of the total concrete produced. These are the challenges now from Indian context in bringing sustainability concepts into this country and make sure that we become carbon neutral, by 2050. So there is a need to minimize wastage of precious material resources by making efficient and judicious use. This has to be concentrated upon. Now, quickly, a few slides on durability of concrete, which is also a subset, as I said, of making concrete sustainable. So we need to understand to a great extent the efforts are on to make the concrete strong, but there should also be effort to make the concrete dense and capable of withstanding the actions that are likely to reduce the lifespan of concrete. So durability generally is defined as the ability to resist weathering action, chemical attack, abrasion, or any other process of deterioration, while retaining its original form, quality, serviceability, etc., when exposed to the environment for which it is designed during its design life. So this is a kind of all-encompassing definition for what we are looking at in durability. So this is, as I said, the key to sustainability. And if useful life of a structure can be extended by using concrete, that's a huge gain for sustainability. So there are two things to look at: the concrete system, which basically consists of materials and processing, and the service environment. That is, what are the physical effects on the concrete structure or structural component, and what is the chemical effects that are there. So there are basically, efforts now to look at this as the target. So the concretes are said to be less durable when they are physically or chemically compromised. Now, physical factors can result in chemical reactions, reducing the durability. For example, cracking due to shrinkage, which is a physical factor, can allow reactive gases and liquids to enter the concrete and chemically alter and spoil the system there. Similarly, chemical factors can result in physical outcomes, reducing durability, like alkali silica reaction, opening up cracks which are physical, allowing other agents like sulfate and chlorides, etc., or carbon dioxide to enter. So physical factors and chemical factors both are things that we need to look at. For example, the external influences for reducing the life of concrete are climate, temperature, sulfate and chloride actions, chemical environment in which the structure or structural component is likely to be, electrolytic action, abrasion, erosion, cavitation, biological corrosion, etc., etc. These are all external influences which will reduce the lifespan of concrete. And internal influences are those which are, what we call as inborn or diseases which are born with the baby, like the type of cement and aggregates, level of chemicals in ingredients, alkali aggregate reaction which can come a little later due to imperfect materials, water cement ratio which might create a havoc, cement content, volume changes, permeability, etc., etc. So many issues are there. Now, what are these things? Let us look at that. What are those which will affect the the durability? One is the porosity and permeability of concrete, the mix characteristics, that is water cement ratio and presence of admixtures. Thirdly, the type of cement and aggregate that are used, presence or otherwise of cracks, thickness and quality of cover. These are main things that we should look at. Of course, there are a lot of transport mechanisms that are there. I wouldn't want to get into in great detail, although there are many slides on this. I would like to rush through and probably have more of discussion with the esteemed panel to understand the implications. So what is important in transport mechanism is because we are looking at the aggressive elements getting into the concrete and spoiling the concrete or reducing the life of concrete, especially reinforced concrete. So the passage of potentially aggressive elements is influenced by the penetrability of concrete. Now, how do we alter the penetrability of concrete is, number one, make it as dense as possible. Make sure that there are no capillaries or the capillaries are discontinuous and the pores are not connected to each other and there are no chemical actions inside. So all of these are connected to the availability of transport facility for the external ingredients, external elements to get in. So transport properties are a key factor for predicting the durability of concrete. So the movement of fluid and ion, includes the mechanism of capillary action, fluid flow under pressure, flow under concentration gradient, and movement due to applied electrical field. So these mechanisms are characterized by the material properties of diffusion, migration, permeability, sorptivity, convection, Wick action, and so on and so forth. So these are terminologies that one should understand to gauge the possibility of these, external elements getting into the interiors of the concrete and hence affect the durability. So diffusion is movement of gases or molecules under the influence of concentration gradient to form an area of high concentration to one with a low concentration. And gaseous diffusion is experienced in unsaturated concrete, while ionic diffusion occurs in saturated and partially saturated conditions. So this diffusion, of course, there are equations and methods to evaluate that. I'm not getting into that. It acts as a predominant mechanism for concrete structures fully submerged in seawater or salt contaminated soil. In combination with other mechanisms of diffusion, it contributes to the chloride transport in concrete under most exposure conditions. So the transport of oxygen in concrete to the steel surface is also governed by the diffusion process. The rate of diffusion is determined by the pore structure, pore size distribution, and its moisture content. So it decreases sharply with the increase in the moisture content. And when you talk of migration, which is also called as accelerated diffusion or electrodiffusion or conduction, this is the movement of ions in a solution under electrical field. So it's a main transport mechanism in laboratory accelerated chloride test, and they are governed by this particular equation. Permeation or permeability of concrete is defined as a measure of capacity of concrete to transfer fluids through its pore structure under externally applied pressure. That's very important, that when we talk of permeability, we talk of an externally applied pressure under which this particular fluid transfer takes place, while the pores are saturated with that particular fluid. The driving force for liquids and gases through the pore spaces or crack network is a pressure gradient. The permeation plays an important role in water retaining structures where water transport through the structure is detrimental. And for permeation, Darcy's law is used. And sorption refers to the uptake of liquids into an unsaturated or partially saturated solid by capillary suction. So this is another mode by which the ingress can happen. It is measured using parameters like bulk absorption or sorptivity. Again, there are equations for this. So this sorptivity is influenced by larger capillaries and their degree of continuity, and it is very sensitive to hydration of outer concrete surface and hence the curing. So it's influenced by compaction, it's influenced by curing and the aggregate orientation and distribution, as well as by mixed composition. Convection or advection is one word used. It's a process that describes the transport of the solute like chlorides or sulfate ions as a result of bulk moving water. So convection along with the diffusion is the main transport mechanism for chloride increase in the cracked concrete, and it also has important role in the movement of chloride ions when concrete is exposed to alternate drying wetting conditions. So again, there is an equation to assess this. And there is also this wick action, which is a transport of water and ions which through the structure from the face in contact with water to a drying phase. So there are combined transport processes that will be there. It's not that there is only one type. There are several paths that will be there, several effects that will be there. So to quantify the combined transport processes, also called as mixed modes of transport, has not been fully achieved. You are not able to, isolate, aggregate, and see the combined effect. So to do this, an in-depth understanding of individual mechanisms is mandatory, and studies should aim at obtaining models for predicting simultaneous movement of these chlorides, sulfates, oxygen, carbon dioxide, moisture, because it's very difficult to see what is the impact of one over the other and their combined movement on the durability. So concrete structures from our side, one is it requires excellent handling of concrete to make sure that the materials are ideal, the gradation of all the materials are perfect so that the densest packing is possible, the mode of vibration, the mode of compacting, the mode of curing are all taken care of. And once you are sure that you have made your concrete the best that it can be made with whatever that you are using, you should also keep an eye on the health of this concrete to ensure that it has the designed lifetime of 70 years or 100 years or whatever that you are planning for. So it requires rigorous inspection during construction and after construction at periodic intervals. That is why structural health monitoring is becoming now a very important and very popular subject. So various tests are required to be carried out to assess the as-built quality of existing concrete structures. One is QA/QC procedure to ensure that the concrete is the best and it's made for durability. Also, there might be certain checks and balances. You may have to check certain components or parts of these concrete to assess the as-built quality of the existing concrete structure. Also, you have to use these tests for checking what is the strength and homogeneity or damages that might have been caused over a period of time due to internal or external agents. Number of equipments, number of technologies, number of methods are available which might be non-destructive or partially destructive. I'm not getting into all the details of those tests, but durability is a function of manufacture. That is, how do you manufacture the concrete? How do you place the concrete? How do you cure the concrete? How do you maintain the concrete? All of these become very important to ensure durability. One small question is using of alternate materials. Is that an issue with concrete using alternate materials? Is durability getting affected by this? So the answer is yes and no. Now, why we say yes and no is, let's look at why yes. The problem is that we have less understanding of the properties of alternate materials. We have less control on the properties and quality of the alternate materials. We have lesser understanding of the impact of alternate materials. And consequently, we may face with undesirable interactions with other ingredients, altered fresh concrete behaviors like reduced workability, excessive bleeding, reduced slump retention, excessive shrinkage cracks, etc., when we use a particular type of alternate material, or altered or impaired hard concrete behavior. All of this could be a consequence of us not knowing fully well what are these properties. I said characterization is very important. Although we undo the characterization, we do the study of concrete, we do the study on durability, still there could be interactions which, we might not have understood or skipped our attention, and we might end up with these consequences. So we may have reduced permeability, reduced strength, delayed ettringite formation, etc. Now, if I want to say no to the same question, what are the answers? That these issues can be overcome, the issues which were in the previous slide can be overcome by proper study and properties of proper study of the properties of alternate materials, following a vigorous quality assurance scheme, ensuring proper mix design procedure, strict monitoring of site practices, proper compaction, adequate curing, etc., resulting in much denser and impermeable concrete with lesser environmental impact, and also concrete with lesser life cycle cost might be. So in conclusion, I would like to say that construction industry has a large role to play in sustainable development, and the drive towards more sustainable construction is achievable only when all stakeholders in the industry, including developers, designers, builders, and suppliers, as well as owners, which I think is missing here, recognize and appreciate its importance. Because if the owners don't realize the need to follow these sustainable construction practices, they might become an impediment with all other stakeholders being in line, which itself is little difficult to achieve yet. Concrete being the most ubiquitous construction material, it is necessary to make it as sustainable as possible, which of course is the basis of this entire presentation. Several groups in several countries have tried different approaches, are trying different approaches with varying degrees of success, which is a good news for us. And durability is one of the most important pillars of sustainability, and design for durability, followed by selection of proper materials and their combination, supported by systematic QA/QC procedures, can ensure durable and hence sustainable concrete. So that's it from my side. I thank the Indian Concrete Institute New Delhi Center and CE&CR and all the organizers for giving me an opportunity to share a little bit of knowledge that is assembled by me here. Thank you very much.
Thank you so much, sir, for the excellent presentation. The sustainability looked from a different perspective, which was not presented earlier to us. So it's a wonderful talk, sir. Thank you so much for taking time and giving your time to ICI New Delhi Center. I now invite Prof. Santhanam, sir, to give his thoughts and opinion on this issue, sir.
I'll first thank Dr. Kalgal for actually taking us on a very interesting journey, because not only did he talk about sustainability, he talks about the facets of concrete that make it sustainable. And then there were also large chunks of information given on specific issues that one can highlight to really take concrete to be more sustainable and so on. I think if there are students and college faculty in the audience, if you just look at this presentation, you can probably get ideas for at least 10 to 20 research projects that you can take up, because there's a lot of interesting work in this subject of sustainability. So very importantly, Dr. Kalgal started out by actually giving an indication of what sustainability is, putting sustainability in perspective before really getting into the knickknacks of how we can make concrete contribute to the sustainability. And that's what probably was the most important aspect, that one has to understand what is the scope of this sustainable impact assessment that we want to do. And based on that, we can apply that to the selection of materials for construction projects to lead us to an effective sustainable option. There were also examples presented of several types of new technologies that are being explored, and some of them are actually already commercially successful, which look at bringing in some aspect of sustainability through a performance perspective. The idea there is to look at sequestering carbon dioxide in concrete on the one hand, and on the other hand, trying to make concrete with alternative materials like geopolymers and so on. There is definitely a great emphasis that we saw from Dr. Kalgal's talk, and in general what we see happening around the world in increasing the amount of replacement materials, alternative materials, which can substitute for cement and extend the lifetime of the cement usage to produce Portland cement based concretes. I think that's a very important perspective that one has to understand, that if we continue to use cement in the way that we use today, we will not be left with any limestone to actually use Portland cement. So understanding the importance of these alternative materials is absolutely there. So I think after he presented all these specific ways of looking at how we can increase the sustainability potential of concrete, he then linked it to the durability of the concrete, because ultimately concrete durability is the key to achieving sustainability in concrete performance, in concrete construction, because a durable structure lasts for a long time. So we save a lot on actually the maintenance costs, and also ensure that we have a built environment for a very long period of time. There are, of course, a lot of intricacies as far as durability is concerned, because one has to be aware of what one is looking at. The importance of transport mechanisms and the interplay between different transport mechanisms as they lead to different durability problems makes it a lot more challenging to address what should we have as test methods to identify such mechanisms in practice, and how do we associate that with the specific durability problems that we expect in a given service environment. So I think overall, this aspect of sustainability has to be looked at in this type of a fashion, so that we can break down the different elements. It's not just always related to performance, it's also related to how we select materials, how judicious we are in use of available materials. For instance, one of the aspects that today is increasingly gaining attention is the use of recycled concrete as aggregate. And that's where I think a lot more emphasis has to be given, a lot more dissemination, a lot more knowledge creation has to be done to ensure that people understand the benefits of actually bringing this kind of a material into play rather than using a natural resource. So I think overall, we are already going in the right direction. We've identified several steps as far as our construction industry is concerned. But I would really echo Dr. Kalgal's viewpoint. I mean, the situation is grim. Definitely, one has to probably be a lot more receptive of these ideas. People in the construction industry have to be receptive of ideas that bring in sustainability. And the discussion in our understanding of concrete has to move from strength. It's already moved to durability to some extent, but it has to go towards sustainability, because unless we talk about sustainability and unless we understand what it entails, we'll not be able to really bring about a judicious use of these alternative materials and really make a true impact on construction practices. So I think that's what I'd like to add. Maybe just for the discussion purpose, I thought of a few questions which Dr. Kalgan can first take up. And of course, he'll have a lot of questions to answer from the audience also. I see the numbers of questions are increasing. So one of the aspects that I thought he could look at is what kind of work do we need to do on the policy stage to ensure that we start putting in place a real requirement of these materials. I mean, given a choice, people will choose the way that is already proven. But if you have to use a new technology, should there be policies in place that help us choose those technologies that will go towards more sustainability. And of course, given the way that the world is moving, when will carbon tax in our country become a reality? Because I mean, we can't be using technologies that emanate a lot of CO2, right? So how do we bring that in our construction practices? Can we build that into specifications to ensure that we actually end up with a lot of innovative methods being followed that can bring down the overall CO2 and energy impact? So these are some thoughts that I thought maybe Dr. Kalgal can touch upon while he answers the questions of the audience. Thank you. Thank you for giving me this opportunity.
Thank you, Professor. Maybe I can respond to what you said in the end.
Sure.
Thanks for your appreciation of whatever little I have spoken. Yes, policies. Now, policy making is one issue. Policy implementation is another issue.
Yeah.
And from what I see in our country is majority of the construction is in the unorganized sector. And imposing any policy on this becomes very difficult. The owner is not aware, the constructor is not aware, and the engineer is nowhere at site. Most of the constructions are non-engineered, although we call them so-called. The only engineering that they use is in planning. After that, it's all under the mason's control. So how do we bring in any significant impact of sustainability or sustainable practices into construction? Of course, the only easier way is to start with infrastructure where there is some semblance of QA, QC and procedures. Now, the government has started doing this, starting from there by introducing certain rules. Like, for example, if a building is, or if a project is more than 100 crores, 20% of the materials have to be recycled materials and so on. Such rules to start with are good start. And what is important is, all of these construction companies also should start publishing what we call as sustainability reports. Sustainability reports now, to start with, cement industry has started. They are publishing every year what have they done in the last 1 year and what is it that they want to achieve by the next year. Now, the similar rule will have to be made, according to my opinion, for all the major construction companies as well as real estate builders, that you tell us how you are going to achieve reduction in your demands of energy, demands in resources, and what have you done. And it should be made mandatory to publish this data. Transparency is the key, because they might fudge some numbers and give, but still it will draw their attention towards these policies. So my feeling is that these are the policies that they have to make and implement it by making it online, making them publish it, going to the site, enforcing all that. Forget it. It is very difficult. India is a very vast country. That way, it's difficult to implement things. Now, coming to common man and coming to house building, which, like I come from a company where we sell 80% of the cement to house builders and 20% of the cement to the infrastructure. Take a few percentage this way, that way. So it is, if at all you have to make an impact in this country, we have to make an impact at this common man's level. Now, common man right now, to pardon me for using the word, doesn't care a damn about sustainability. For him, it makes no, see, what is there in it for me is what he will look at. So unless he has certain incentives for using alternate materials and making it sustainable or green, let's say you say that I'll give him 5% reduction in the house tax, then he will do it, because that's a long-term saving of money, and the government is not going to lose a huge money because of this. See, government has entered into agreements in Paris or any other place saying that they'll reduce, and the biggest sector being the house building sector, the only way to convince the people to use sustainable practices is to incentivize. And I think that is one way in which I feel we could start. It could be a good start.
Thank you.
Thank you, sir. Thank you so much. Sir, there are some questions from our attendees. If I can ask one by one, maybe some of them are interesting, some are just like that. So the first question.
Professor Manu is also there, so I am confident that it can be answered either by him or me.
Yes, sir. There is a question like how to reduce the quantity of clinker components. I didn't really understand what does it mean. How to reduce the quantity of clinker components?
Quantity or quality?
Quantity, he says. Quantity.
Quantity. Okay.
Yeah.
So quantity is how to reduce the quantity of clinker is to
clinker components. Components, he says.
Probably he means clinker part that is in the cement. Let's say 40% of clinker or 50% of clinker or whatever.
Right.
So clinker reduction is only by introducing from the other side alternative cementitious materials. But one has to be careful when you reduce cementitious, the OPC content or the clinker content. There are some attendant issues which will come, especially in low grade concretes. In high grade concretes there are no big issues, but then there are some issues because of which the BIS is trying to restrict the clinker component not less than 50%. They want clinker to be present. So this of course is debatable, but then that is what the mandate is likely to be, either for composite cement or for blended cement or for LC3 and so on and so forth. So that is what I would say as far as reducing the quantity of clinker is concerned.
Thank you, sir. And one more question, sir, from Mr. M.V. Bhaskar Rao. He says, why, in terms of using energy, natural energy, usage of solar energy should be encouraged in the design of buildings itself. Is it a possible solution?
Sir, solar energy we've been talking at least for the past 20 years or plus. That solar energy is good. At least they started with for heating water. Now there are governments which are encouraging them to put solar on top and also sell it to the grid. So these two are already in place in most of the places, and a lot of people have awareness today about solar. So I don't think we need any incentive. The fact that they can save on electricity bill itself is a good incentive for them to go in for solar panels. And solar panels rates also have come down from what it was when we installed solar panel in my house in 1980s to what it is today after 20-25 years. There's a world of difference. It's worth it. So it's already happening, sir. Of course, large solar parks, of course, the government is doing and they're generating solar energy. That is there. But at the individual house tops, you will see that most of the houses now, at least in urban areas, 80% of the houses have solar water heater, not solar electricity. So solar is becoming popular on its own.
One more question, sir. Somebody also Mr. Harising. Can we use fly ash probably in concrete, in segmental concrete construction?
Segmental concrete construction is generally a pre-stressed concrete construction. Yeah. So in pre-stress, one of the requirements or expectations of the builder is to have quick early strength of that 0.7 FCK or 0.75 FCK that he wants for stressability or for stressing it. Yes. He wants it in 3 days. So if you use too much of fly ash, it may not achieve the strength in 3 days. If he is ready to wait for a few days, why not? You can use blended cements for even pre-stressing. But of course, you have to look at the codal requirements, codal permissions, and so on. So segmental means the first thing that comes into mind is pre-stressing.
Pre-stressing.
So from that point of view, fly ash will have to be looked at with whatever constraints that are there.
So, well, maybe this person doesn't know why no research was made on construction material like a cement and concrete, but a lot of research is going on. I think.
I don't think we need to answer that.
We need to answer, yeah, right.
He has to only Google. He will know how much.
Yes, exactly. Yes, yes. Cement replacing building material. Of course, you already spoke about that. What is the regeneration of raw material used in concrete? I didn't understand really what is it.
Regeneration, probably he means this recycled concrete.
Right.
So there is no other regeneration possible.
Exactly.
That is also happening. That is also happening now. More and more plants for recycling have to come. The availability should be there, and then confidence level in the people to use recycled materials has to go up. The biggest problem in recycling is the segregation. You know, material gets mixed up. Unless you are able to segregate, you can't use it. You will have mixed properties and mixed issues and so on.
Sir, but in fact, a question from my side, sir, how to increase the marketability of these recycled aggregate? Because you know, the famous company went bankrupt, which was involved in the recycling of the concrete in Delhi.
I know. Yeah, there are 2-3 plants which after that nothing happened.
Nothing happened.
But the good news is there is another new company called Dr. Sand, which has come now.
Okay.
Who are planning to come in a big way into recycled aggregates.
Right.
See, the basic one is that there is no demand because there is no supply, and there is no supply because there is no demand. So this keeps happening. But only when government has made it mandatory that in major projects recycling is a must. Like in I think some buildings which got demolished in Rohini, they said all of that has to be recycled. So when government intervenes, it will start, and it should start with bigger projects so that people say, oh, in that project recycled material was used, so I also can use. So that confidence will take time, but it will come.
It will come. Yes, sir. And somebody asked nano cement usage in concrete construction. Nano cement.
No, nano cement is one approach that people are trying, but you see, these are nano cements are extremely costly, which is obvious. And in the repair segment, there are some applications where nano cement is used for manufacturing products which are used for repair. So it's not a common material, and it's not required to be used for general construction. The biggest consumption in India is from M20 to M30 in majority of concrete. You don't require a nano cement for that.
Right, yes, sir.
If you are going for UHPC, maybe yes.
Yeah. Sir, again, one question from my side, sir, again, to intervene. Actually, we did some R&D study on high strength, high volume fly ash concrete. So we used up to 60% of fly ash, unprocessed raw fly ash, and by using the nano silica, a small portion component, very small, and we could get a property equivalent to normal OPC concrete, early strength also. So
yeah, road sector, a lot of pioneering work has happened in road sector only. In fact, even Professor Shah, RJ Shah has done a lot of these, use of nanosilica or any other nanomaterial for the pavement concrete only. So there is a potential, there is no doubt about it. But handling, using, sonification and so many other factors that are involved in using of nanomaterials. Right now, it is not so easy to be used by. Again, I come to that common man. Ultimately, the impact will come when common man uses it. Okay, I'm not saying that it should not be used. It should be used, but we all should try to see which are the low-hanging fruits as far as the common man usage is concerned, because that volume is going to bring in a big impact in our country.
Okay, sir. Sir, one builder raised a question: how to pour concrete at the waterlogged area?
How to put concrete at waterlogged area? There are 2-3 ways. One is if you can, bifurcate, divert water by pumping, create a dry surface for concreting. That is one. The other one is if you want to put it underwater, there are anti-washout, admixtures that are available. So you can use that and pour the concrete even in running water. I mean, people have done this. But the best way is to barricade, isolate the area, make it as dry as possible, and pour a little quick setting concrete so that you will have a good control over shape and things like that.
Sir, some compliments for you, sir, from Professor Bhattacharya of Delhi, our common friend.
He is our guru.
Yes, sir.
It is his blessings to us.
So, Dr. Bandhu from Calcutta, they all actually appreciated your work, sir, and given compliments to you. And there's one question, sir. When using alkali activated material and geopolymer material, can we use the same durability test carried out as for cement concrete?
Sir, once the concrete is made, this is my opinion, Manu can substantiate or discount me. See, we are looking at performance, right? Now, whether we made it using geopolymer or normal concrete, what I am expecting from that concrete is the same. Okay, but, the transport mechanism should be handled. It should not, allow, these ions and other things to go in. So if I can achieve that, it is my purpose is served. So the test methods in general may have to be maybe the same. I would like to know from Manu whether it is wrong.
Yeah, I agree on mostly with that. Only problem is when we do these test methods that involve migration, which involve application of electrical potential, because in geopolymer concrete we use a lot of alkaline activators, and these alkalis sometimes are free in the pore solution. So even if the concrete is durable, sometimes the result shows that the RCPT value is very high. So you need to actually do a combination of tests, like a water absorption test or a gas permeation test in association with chloride-based tests. So tests based on migration may not be easily applied to geopolymer concretes, just like we have the issue with steel fiber concrete. So steel fiber concrete would be durable, but then because of the steel fibers being present, giving continuity for the electrical conductance. So migration-based tests need to be carefully applied. That's the only thing. Otherwise, as you were rightly saying, water-based tests, they should end up producing same durability in geopolymer concrete also.
Sir, one more question, sir. To reduce the porosity of LC3 cement, so as to reduce carbonation, what should we do?
Professor Manu?
He's the boss.
This was LC3. LC3 is it?
Yeah, because it is LC3, I'm passing it to you.
Yeah.
No, see, the porosity of the concrete is what needs to be reduced. And for that, the choices, of course, are to use a low water to cement ratio in the system, provide adequate curing. So just like we do for ordinary Portland cement concrete. In general, LC3 concrete will have a lower porosity, or rather, not a lower porosity, but a lower pore size as compared to plain cement concrete. When you have a lower pore size, the pore connectivity reduces, and that leads to a better transport characteristic that reduces the problems in durability, like chloride ingress and things like that. Right. It makes concrete more impermeable. Yeah.
So there one more question, sir. Shall we go for calcium sulfur-aluminate cement as a low CO2 alternate binder?
In BCT, it is already being tried, but generally this is again for very fast setting and high early strength development kind of application. Calcium sulfur-aluminate is available in our country majorly from China, but used only for some niche applications, not as a general purpose cement. That is what is my understanding.
As a general purpose, I think they're trying to market it as a calcium sulfur-aluminate B-light cement, so CSAB. But then again, I think we need to find the ways to manufacture it here if it has to be commercially viable.
And there was a question like, can we use fly ash as alternate material, or is this PPC allowed for using alternate material in concrete and all? I think PPC is being used at many places, including So, what specific steps should be taken to make skilled laborers in India for maintaining good quality control?
Well, this is a big question which everybody is trying to solve. Number one, our country is big. Now, number two, the education level of the workers is, many a times they are even just third standard, fourth standard people who join as coolies or workers and then graduate to become masons and so on. So to impart, training to them is a little difficult. Not impossible, but difficult. See, today in India, for fitter, welder, turner, you all require ITS certificate. But for a mason, you don't require any certificate. Now, we need to bring this concept of, again, certification being mandatory. Now, when you ask the government to make it mandatory, they'll say, where are the trained masons? Now, when you ask masons to get trained, they'll say, why should I get trained?
Right.
So this is again same story. So again, it should start that in major projects, they should say 20% should be certificate holders. Now, incidentally, companies like UltraTech, they do a lot of training. In fact, UltraTech trains something like 50,000 masons every year on basic construction skills in effect of water cement ratio, how to store materials, how to avoid wastages and so on. They give a fairly good training. But the biggest problem that we are facing as trainers is also that the masons don't want to come for training. They'll say, if I come for 1 day training, I lose 1 day's wage. Now, do you give me the wages? Now,
Right.
if somebody is wanting to train, you also expect him to pay. That is difficult. No, so many of the people are refraining from training. So these is again, the contractors will have to spare them for a few days to get trained and so on. The training is the only way. Now the government has come up with this skill development department, but if you look at their syllabus and their expectations, it is impossible. They are saying 6 months training. Now you tell me, who will come for 6 months, leaving everything else? What about his livelihood? Who will take care of his livelihood for 6 months? So you should have a system of evaluating the construction mason at site, finding out the skill gap and topping up his knowledge. Now this is a flexible syllabus mechanism that they have to build in. And these agencies who do this, see, the biggest problem, again, it's an open forum, I am not supposed to say, but then the minute you put any such rules, there are 100 agencies who will bring in bogus methods of giving certification. That defeats the whole purpose. So if you make it mandatory anything, there are people who will misuse this, and that becomes very rampant. So the only way is to go from site to site or from area to area and train those local fellows in the evenings in local language by some CSR funding. That's the only way I see us going forward.
I would like to add something to that. Hello. Now in CPWD, now we are making a condition in our contracts that 20% of the labor should be trained to be employed by the contractor. But since trained labor is not available, what is happening is that we have tied up with National Skill Development Corporation. They have approved certain agencies to impart training to the workers. And this training is done at the site only. Like you said, the agency comes, they evaluate the gap in his skills and the required. What is the requirement?
Exactly.
And accordingly, they train him for a few hours. I think around for 1 hour for a few days. And that training is done at site and no wages are deducted from the contractor. Payment is done by CPWD for that training. And the contractor has to provide space for the training and he has to arrange that the workers come and attend the training. And they provide them the tools. So it is easy for the contractor, easy for CPWD also because we have got government funds to pay for that. But the problem is the contractors say that once the labor is trained,
He will go.
They leave. Because now they feel that they themselves have become contractors. They can, they can do work on their own. So they leave them. So that way they have no interest in training them. The only thing is, since there is a requirement in the contract that they have to get the labor trained, so they are forced to do it. But from their heart, there is no moral pressure on them that they should get them trained because they say, sir, they will leave us. Once we train them, they will leave us. So, this is a big problem. Even though government has, is alive to the necessity, but it is very difficult to get the labor trained, because the contractors, they don't like to train their labor. Yeah.
Thank you, sir. Sir, there is a question from our ICI colleague and a friend from West Bengal, Professor Debashis Bandyopadhyay. What are the interactions between the 5C aspects of sustainability with the durability aspect of the concrete? What is the percent contribution of the different aspects of sustainability?
Now 5C, it's all, it's like a part of the same, jigsaw puzzle. You have an approach which brings in the reduction of whatever way possible to reduce the impact in cement, whatever the way to reduce the impact in concrete. These can be independent as well as collective. Now, whatever improvement that you bring in, or reduction in the carbon dioxide equivalent in cement, can also be brought in to some extent from concrete and also from construction. But quantification is difficult. I mean, they have given some kind of a estimate that they will reduce it to virtually, see, they are talking of carbon neutral, that is by 2050 it has to become zero. Now, but the effort has to start now in 2020. Already it's happening. Now the GCCA people or SEMBRO people, they are all working with their agencies. SEMBRO approach is different because most of the European concrete is ready mix concrete, or it is organized sector. But to bring in the same concepts in India is not possible. So here GCCA, of course, is trying to approach it in a different way. But the quantification or the interplay between the different approaches, it is still not clear. They are all trying right now different angles to make it as sustainable as possible.
Thank you, sir. There is a question on recycled aggregate strength actually. Does it have the same strength as the original ones? Naturally, it doesn't have actually. So,
it depends on how much of material is sticking to it.
Right, exactly.
If you can remove all the materials, it becomes as good as virgin aggregate. But then there are later things which are sticking to it, which is very difficult to and costly to remove. So you will have to use it with a little inferior performance. But there are ways to handle it.
Right. So the one more question: how SDC, the full form, differ from SCC?
See, smart dynamic concrete is one terminology, and self-compacting concrete is another terminology. Smart dynamic concrete is basically a high flow concrete, not exactly a self-compacting concrete. Self-compacting concrete is, very well engineered, but it is a little costlier. This is a kind of mid-range PCE application to get, whatever high flow that you want, but it need not be as superior as SCC. That's all I can say at this point of time.
Sir, is it possible to make a denser covercrete relative to corecrete, like a TNT bar, to ensure greater durability?
You can't put a bifurcation that cover has to become this, core will be something else. We are not manufacturing sandwiches. No, we are manufacturing.
Sir, what are the methods to improve the porous pervious concrete? Strength of pervious concrete.
Strength of pervious concrete, very little you can do.
Yeah.
Because it's almost like a no fines concrete.
Right.
So then if you have to make it stronger, you'll have to make it denser and hence less pervious. So right. I don't know any method to make it very strong unless you dip all the aggregates in epoxy.
Sir. Well, sir, one more question. We're also doing research on this topic. Can we produce SCC with recycled aggregate and fly ash as mineral admixture? Research work is, paid work is going on, sir, with one of the students.
Yeah, and it is again, you see, fly ash, what kind of fly ash? Aggregate, what kind of aggregate? Application for what kind of concrete? So all of these are variable parameters.
Right.
Yes and no, it can be done. I mean, okay, it's a matter of the whole concrete mix proportioning is a matter of trial and error. So if we know how to systematically do the trials, we might achieve these things, whatever that we want. But there will be limitations depending on the type of aggregate, especially.
Yeah, definitely, yes. The flow and all will get affected depending on the quality of the concrete aggregate actually.
Yes, yes.
How to protect underground concrete surface from chloride and sulfate attack? This is
Sir, generally sulfate attack and other things are all function of permeability. And for chloride things to act, oxygen should be available. Underground structures generally don't have this issue because there is no oxygen available underground. This is my understanding. Manu, you can correct me.
Yeah, so in general, I think even in concrete structures that are embedded, the corrosion is more at the air-soil interface rather than underground. Nevertheless, when we are choosing foundations, we try to make them more durable by choosing, for instance, if it's a chloride or sulfate-rich soil, we choose blended binders like slag. If it's chloride, mainly slag. Sulfate, as Dr. Kalgal pointed out, primarily we need to reduce permeability. So we need to reduce the amount of water in the concrete, reduce water-cement ratio.
Thank you, sir. Thank you so much, Dr. Kalgal, sir, and Professor Manu Santhanam, sir. Now I think we have come to the end of the questions session. Now I request that our engineer B.B. Vadhwaji, our treasurer of ICI New Delhi Center, to propose a vote of thanks. Thank you so much, sir.
Thank you.
Thank you so much. Good evening to the respected speaker, panelists, moderator, all participants, and organizer of this webinar. First of all, I would like to thank the organizer giving an opportunity to express my gratitude and thanks everyone, which is an honor for me. On behalf of ICI-NDC, I would like to thank Honorable Speaker Dr. Kalgal for his wonderful and enlightening presentation on the topic durability and sustainability of concrete structures, highlighting the modes of sustainable development, that is economical growth, employment, and improvement of environment by minimizing the external and internal pollution. He emphasized for making cement more sustainable by using supplementary cementitious material. Dr. Kalgal also suggested to use recycled and alternate materials and advanced means of construction to minimize CO2, as being adopted in other developed countries. He suggested keeping an eye on the selection and quality of construction materials, proper testing, insist on rigorous inspection during and after construction to make it more sustainable. He suggested that government should to offer some incentive or rebate in house tax, etc., who make green and sustainable structure or building. I thank you very much, sir. I also extend my thanks to our eminent panelist, Professor Manu Santhanam of IIT Madras, for consenting to be part of this lecture and offering his valuable feedback and comments. He emphasized on use of recycled and other alternative materials in construction industry, but also to ensure adequate durability and strength. A concrete policy is essential to control the emission of CO2 is essential to be made in this country. Thank you, sir. Thanks to Dr. VVL Kanta, today's moderator, for very well handling and carrying out the webinar.
Thank you, sir.
Thanks to Engineer Supradeep Das, Vice President North, ICI, for presenting the role and activities of ICI in detail and its future development plans. I would also like to thank our India ICI President, Engineer Vinay Gupta, though he is not present today, for motivating, inspiring, and guiding towards the upliftment of concrete technology through organizing lectures, seminars, workshops, etc. throughout the country. I want to express my gratitude to Engineer Rajiv Singhal, Chairman, along with all executive committee members of ICI-NDC, for their sincere efforts in arranging and organizing this type of webinars. This is the 6th webinar in the series. Heartfelt thankful to CE&CR and Revered Media for their logistic support and making necessary arrangement in organizing this webinar in shortest possible time. Last but not the least, I'm also obliged to all the participants and express my gratitude for their active participation and making this webinar very successful. As requested by our chairman, the participants are requested to strengthen this organization by becoming the regular members of Indian Concrete Institute so that they can have the window for the latest concrete technology updates. Thank you, everyone, and thank you very much for making this webinar successful. Thank you very much.
Thank you, sir. Thank you all.
With this, sir, with the close, sir. Thank you so much.
Thank you.
Thank you.
Thank you, sir. Bye.
Thank you so much, sir. Yeah. Bye. Vijay, namaskar.